Kia ora. In this STAT193 video, we're going to carry out a large sample hypothesis test for the mean using a graphics calculator. A questionnaire designed to measure the social connectedness of a person contains a sequence of questions about their life situation, family, work, and friends. On the basis of the responses given, a connectedness score can be calculated for that person, with a higher value of the score indicating greater social connectedness. When the questionnaire was administered to students in the USA, the mean score was 3.10. Researchers using the social connectedness score are concerned that the questionnaire might give different results in New Zealand. A random sample of 51 students completed the questionnaire and their mean score was 3.20 with a standard deviation of 0.51. In this problem, we're going to carry out a hypothesis test at the 5% level to test whether the mean social connectedness score among New Zealand students differs from the US value of 3.10. Okay, so we're going to carry out the 4 steps for a hypothesis test. In the first step, we need to set up our hypotheses. We start by setting up our null hypothesis. Now this involves us looking at the status quo, so nothing being different. So New Zealand students and US students having the same mean. So that is a value of 3.10. So here's our null hypothesis, that the mean for New Zealand students is equal to 3.10. In order to set up our alternative hypothesis, we need to look at the keywords that are in the problem that we've been asked to do. The key word we're looking for here is the word differs. So we're interested in testing the alternative hypothesis that the New Zealand mean is different from the US value. So this is not directional. This just means we're not looking at greater than or less than. We're just looking at it being different. So the way we set this up is that the mean does not equal 3.10, and that's our alternative hypothesis. Because we have this does not equal sign in here, it's a two-sided test, and the alpha of 0.05 comes from this 5% level here. In the second step, we need to report the summary statistics and calculate a test statistic. So we look to our problem, and we can see our summary statistics here. Our sample mean, our sample standard deviation, and our sample size. So we report these. Next, we're going to calculate our test statistic. So we go into the Stat option of the main menu. We select Test, which is F3, and we've got a number of choices here. Now we're testing for a single mean. So our choices are between Z and T. In order to choose between those two, we take a look at our sample size, which is 51. This can be considered to be a large sample, so we choose Z, which is F1. We're again testing for a single mean and its value, so we choose 1S. We check that data is on variable, and we come down and set up our alternative hypothesis. We've got the choice between does not equal, less than, or greater than. So we've used the does not equal sign, so we select F1. We come down and now need to set the value that it doesn't equal from our alternative hypothesis, and that's a 3.10. We now need to enter a standard deviation, which we'll use the sample standard deviation for, our sample mean, and our sample size. And we can execute that. That gives us our test statistic, which is the Z value here, of 1.40 to 2 decimal places. The next step is to report our p-value. That's also been calculated for us here at 0.1614. Now if I just exit out of this for a moment, this is the screen that we entered all that information, and I arrow down, we can draw the distribution, the normal distribution, and show the p-value shaded. So because we've got a two-sided test here, we can see that the p-value is shaded in both tails. So we can reproduce this, drawing a normal distribution curve. the limits or the boundaries on those shaded areas are going to be 1.4 from our test statistic here, and also the negative 1.4. So we shade those tails there. In the final step, we draw our conclusion by bringing all this information together. Now, the way we make our decision is that if the p-value is less than alpha, we reject the null hypothesis. However, if the p-value is greater than alpha, we do not reject H0, the null hypothesis. In our case, our p-value of 0.1614 is greater than our alpha value of 0.05. Therefore, we do not reject the null hypothesis at the alpha equals 5% level. That is, we do not have evidence against our null hypothesis.